Hello there, welcome back. This is another 8th grade math video where we're going to be working on comparing rational numbers. And if you're not sure what a rational number is, those are positive and negative decimals and fractions. Okay, so let's start with this one. We're going to compare these two rational numbers. Now, these are both fractions. One is 1/2 and one is 3/4. So I'm going to go ahead and rewrite them this way because I prefer to look at my fractions where the numerator is directly on top of the denominator. Okay, so since they're both fractions, we could change them so that they are fractions that have the same denominator. That will make them easier to compare. Another way we could do it is we could say, well, 1/2 is the same as 1/2, and 3/4 is bigger than 1/2 because 2 would be half of 4. So there's that way you could do, and you could figure out that, oh, 3/4 has to be bigger. Or if you want to change them so that they have the same denominator, just to be sure, what you can do is look at the smaller one and ask yourself if you can multiply it to get the larger one. And in this case, you can. You can multiply 2 times 2 to get 4. So I'm going to go ahead and multiply the top and the bottom of that first fraction by 2. 1 times 2 is 2, and 2 times 2 is 4. So that's how I can change it into an equivalent fraction that has 4 as a denominator. So now I'm comparing 2/4 to 3/4, and 3/4 is definitely bigger than 2/4. So again, 3/4 is bigger than 1/2. So that's a couple different ways you could do this. Okay, here is our next one. We're comparing these rational numbers, -6/10 compared to -3/5. Now they are both negative. So when you're comparing two negative numbers, remember to keep in mind it's more about which number is further away from 0 than the other one. So let's go ahead and rewrite these. -6/10 compared to -3/5. So again, to make it easier, since they're both fractions, I'm going to look at the smaller denominator to see if I can multiply that to get the greater one. And I can. I can multiply 5 times 2 to make it 10. So I'm going to do the same thing to the top of the fraction. That'll keep it equivalent, but it'll have a denominator of 10. So that means -3 times 2 is -6, and 5 times 2 is 10. And then I'm going to compare it to -6/10. So now I can see that after I change them, that they're actually equal to each other. They're the same number. So neither one is bigger. They are equal. Okay, here's our next one, comparing the rational numbers -5 and 7/16 to 4 and 1/2. So let me go ahead and rewrite those. -5 and 7/16 compared to 4 and 1/2. Okay, so now this one brings up an interesting point when you're comparing. Now, when you're comparing two numbers, either rational numbers or integers that have different signs. Now, if you're not sure and you want to hear me talk more about that, I do have a previous video where I talk about comparing integers, and we talk about this as well. So whenever you have two numbers with different signs, one's positive and one's negative, the positive one is always going to be greater than the negative one, no matter how far away from 0 they are, because positive numbers are always greater than negative numbers. So I don't really have to do any recalculating or anything here. I already know that 4 and 1/2 is the bigger one. Okay, here's our next one. We're comparing the rational numbers, -6.2 and -6.4. Now, these are both decimals, and we haven't done that yet. And they are also both negative, which means when we're comparing them, we want to see which one is furthest away from 0. So we're going to kind of draw a little number line here. And I'm going to put 0 all the way over here because we're only dealing with the negative side of the number line. Okay, so since both of those have a 6 as their whole number, I'm going to go out to 6. 1, 2, 3, 4, 5, 6. So here's -6. -6.2 is probably just beyond or just 0.2 farther away from 0 than -6. -6.4 is just a little bit past that because that is another 0.4 or 4/10 further away from 0. So I'm going to go ahead and label these 6.2 negative, and this is -6.4. So we can see that the one that is actually closer to 0, which means it's bigger, is -6.2. So I'm going to make the symbol open up to that number. Now, this also feels a little strange because we're used to 6.2 being less than 6.4, but not when they're both negative. When they're both negative, we have to look at which one is actually closer to 0 to identify the bigger one. Okay, here is our last example for today's video. We're comparing the rational numbers 13.0 and 13 to decide which one is bigger. So when you have a whole number and a decimal, it's easiest, or even when you're comparing any of these rational numbers, it's easiest when they're in the same format. In this case, one is a decimal and one is a whole number. So to that whole number, I'm going to add a decimal, and I'm going to add a 0 in the tens place because it has no tenths. So I'm just going to go ahead and do that. That way they're both decimals that go out to the same place value. Now we can see after I did that they're exactly the same. So these are actually equal to each other. 13.0 is the same as 13. All right, you guys, thank you so much for joining me today. I hope to see you in another video soon.